Well, aloha, and welcome to the very first lecture for Biology 110, or People in Nature, here at Chaminade University. Today we'll be talking about ocean pollution, which is Unit 1 of this course. So some of the major contributing factors for ocean pollution include oil spills, sewage, and things that come from the groundwater runoff, things like fertilizer and chemicals, including things like mercury and radioactive compounds, and agricultural waste. And then last but not least, we're going to do a little bit more extensive overview of the Great Pacific Garbage Patch. So we'll talk about how that comes from garbage overflow, and then what the resulting uh, impact on the oceans are. So let's take a look at the pollution in our oceans. What is it polluted with? Well, in some places it's polluted by toxins, right? So here's a chemical spill or something like an oil spill on the surface. It's also polluted by garbage. Here's showing a lot of garbage waste. Most of that is going to float on the surface, and this can be really detrimental to the marine system because some of this is going to look like food to things like turtles, etc. Additionally, it's going to break down into microplastics, so small little microplastic beads that can get ingested by marine life as well. We also see it in the form of oil spills. So here's an example of an oil cleanup of a large oil spill. Sometimes we'll see overrun of fertilizers. So if people over fertilize their land and then the fertilizers end up in the groundwater, then we can see what's called eutrophication, and we'll talk about that in just a little bit. We can also see sewage runoff or random chemicals that have been let loose from, for example, radioactive chemicals from a nuclear power plant meltdown. So there's a lot of different things that can contribute to ocean pollution, and we'll talk about them one at a time. So let's start with oil spills. Oil spills can be very detrimental to the environment. They have a huge economic impact, a social impact, and obviously an environmental impact, right? We've all seen the images of the little ducks that need to be saved by dawn. Um, but people are affected as well. People lose their livelihood if they're, for example, they're fishermen or if they run a tourist business. And the cleanup costs are quite extensive and can cost the city and county great amounts. And often we're also talking about extreme destruction of marine animals and marine plants. So the marine environment is completely decimated, usually, if not extensively harmed. Additionally, in order to clean the chemicals up, right, in order to clean up the oil, these chemicals are not really going to be good for the environment either. And even if we do our best, it's going to be impossible to remove all of the oil that's been spilled. So even after extremely long periods of time, over a decade or so, you're still going to be able to find trace amounts of oil in the environment. So it's one of those very difficult, takes one moment to make that mistake and is very difficult to take it back. Additionally, sometimes oil can go down with a ship. For example, if a boat gets sunk for whatever reason, and then it ends up without having the oil removed, and so that oil can end up lodged inside that boat and eventually end up resurfacing. If something like, for example, a cyclone takes the ship and smashes it around, you can end up with a release of that oil, and that can end up hitting into the groundwater and into the ocean as well. And this had actually been sunk since World War II, and yet it took until 2001 for something really large, a large cyclone, to be able to release this oil. So it can sit there for a very long while, a kind of like a ticking time bomb, until something like a natural disaster sets it off. And in this case, it took over 2 months of leaking of oil and gasoline before they were able to stop it. And it actually was a huge impact in the local environment because there were over 700 islanders who were in that atoll who rely on that reef for fishing. And so they were actually unable to feed their families. And this is only one of hundreds of shipwrecked tankers. There's tons of these around the world. So they're all kind of little mini time bombs for oil spills yet to come. Another ocean pollution comes from sewage pipes. So in a lot of parts of the world, particularly in third world nations, sewage flow is not treated when it hits the ocean. Or if it is treated, it's treated in an undertreated fashion, so it's not treated as well as it ought to be. An example that we're using here is the Mediterranean Sea, where approximately 80% of the urban sewage is actually discharged untreated into the Mediterranean Sea. And here we can see a scuba diver who is sitting by the sewage flow, just watching all the sewage flow into the ocean. And the sewage is going to be able to cause something called eutrophication, and we'll talk about eutrophication in a minute, but basically it's an excess of nutrients in the water, which can lead to a loss of oxygen. And it sounds kind of counterintuitive, but we'll discuss it in just a second. But additionally, it can cause human diseases, right? Nobody wants to go swimming in the sewage, and the sewage that ends up on the beaches can come in contact with the bathers, etc. So it can lead to beach closures and loss of tourism as well. So what is eutrophication? So eutrophication is defined as an excessive enrichment of nutrients. Basically, it's water that has excess of certain natural substances or artificial substances, but mainly nitrates and phosphates. And these are found in your fertilizers. And when they get into your aquatic system, they end up causing these giant dead zones. And that sounds like, well, that doesn't make sense, right? If you're adding a whole bunch of nutrients, how can it cause death of organisms? And that basically happens because the extra nutrients are going to lead directly to algal bloom. So when the algae bloom, they're going to take over the surface of the water, right? And eventually they're going to run out of the nutrients, so they're going to die. And when they die, they get decomposed by certain microorganisms like bacteria, and that process depletes all of the oxygen in the water, and that's going to suffocate all of the other marine life. So this is going to form dead zones where anyone that swims into it is going to be unable to get the oxygen necessary for survival. So that's going to be incompatible with marine life. Some other ocean pollution can come from hazardous chemicals. Some examples might be something like heavy metals, like mercury. And mercury is something that is going to accumulate in organisms. So it's a bioaccumulated, and what that means is that it can be eaten. A small organism that has mercury can be eaten by a large organism, and even though that organism passes everything else of the first organism out of their body, the mercury ends up inside of it. So large fish that eat smaller fish can end up becoming concentrated with the mercury in their bodies. And that also can be an increase in the surrounding water or soil. And this can be very bad because we can end up with animals that, again, that have an increased chemical load of this mercury. And people can be contaminated with mercury as well, either from, it can happen from household products or from contaminated groundwater, but it can also happen by eating seafood that is contaminated with mercury. And mercury consumption is very bad for people. It can result in vision loss, muscle impairment, deafness, and speech impairment, and also deterioration of movement and coordination, which happens when you have weakened muscles and poor vision. Another example of a hazardous chemical is the Fukushima disaster. So in 2011, there were thousands of tons of radioactively contaminated water released from the Fukushima complex into the ocean. And this was disastrous for the local environment. Additionally, radioactive pollution leached out of the contaminated soil from the incident into the water table, and then that water runoff fed directly into the ocean, so that also added to the radioactive load, and this actually increased the radioactive load for many, many years to come. So it wasn't just from 2011, it actually was an additional impact over the next decade, or, well, haven't hit the next decade yet, but we're close. In addition to this, we also had something called atmospheric fallout, so that's when we have little particles of the radioactive matter that are actually dropped directly onto the ocean. And it's a radioactive particle, is CS-137, and was actually found approximately 30 kilometers out into the sea just from this one incident. And then after that, it became widespread because the winds carry that radioactivity everywhere. So it became a very prevalent problem in all of the Pacific Ocean. Now, I'm just mentioning these two examples, but there are many other chemical pollutants that are found in the ocean as well. And man-made chemicals can be very dangerous to humans and other organisms, causing severe health problems, things like cancer, immune failure, behavioral problems, reduction in fertility. And so, again, this is a very widespread problem for all of the organisms on the planet. So let me talk for a second about the Great Pacific Garbage Patch. You've probably heard about this in the news. Where does it come from? So most of our ocean pollution actually comes from the land. Over 80% of it comes from the land. Now, approximately 20% of it does come from different accidents at sea where we might lose cargo into the ocean, etc. But most of it comes from water waste that is already contaminated with whatever the pollution is that then runs into the ocean. And approximately 90% of the floating materials, so all of the floating trash essentially, is plastic waste. And plastic waste is really deleterious, really harmful for seabirds and sea turtles, for example, because they can often mistake this for food. And oftentimes parental seabirds will actually, they regurgitate their food back to their offspring, and so they'll go out and pick up something from the sea, and it'll turn out to be a little piece of plastic, and then they'll regurgitate it into their offspring, inadvertently actually killing their babies. And so this can be really, as I mentioned, terrible for the bird population, but sea turtles also, they'll mistake plastic bags for jellyfish, which is their primary food source. And then we also talked previously about oxygen deficient water zones, where we have dead zones, where basically they're completely incompatible with biological life. And the amount of these dead zones have drastically increased over the past couple of years. So what happens? Basically, we have plastic waste that is going to be dropped into the ocean one way or another. Once it's deposited, it's going to accumulate in specific regions, right? And that's going to lead to these giant garbage patches. And these garbage patches cannot support biological life, right? Because all of this trash, these little pieces of trash, can end up being consumed by and end up in the stomachs of these organisms, which are unable to digest it, and it just causes severe blockage, if not poisoning, and eventually they end up starving to death with a full stomach. So this is just demonstration of the fact that it is completely incompatible with biological life. Now this one is not plastic, this one is netting, but you can see this whale is filled with plastic. So these organisms are unable to consume the food that they were going to consume because they have all of this plastic in their bellies. There's another example of a sea turtle with the plastic in his mouth, another sea turtle going after these plastic bags. So you can see they look a lot like jellyfish, and these guys don't necessarily know the difference. The seal here is unable to eat because it has a ring around its mouth, so even if it has food that it might encounter, it's going to be able to physically open and swallow it. And we see that a lot, right? We've all learned that we have to cut our six-pack rings every time that we go to throw them away, on the off chance that perhaps they do make it into the ocean, so that we don't end up with turtles that have it caught around their neck. But the plastic problem is very real. So the world produces 300 billion pounds of plastic every year, and 30 billion of it ends up in the ocean. Now, most of that sinks, 70% of it, but the rest remains is what we call surface plastic. And surface plastic is just going to sit there on the top of the ocean. And unlike some organic trash like your food waste, plastic doesn't break down. It's completely non-biodegradable. Now, it does break down into smaller pieces. So it breaks it down into smaller and smaller pieces called microplastic, but then we end up with these microscopic pieces of plastic that end up eaten by smaller marine organisms and still enter into the food chain. And when we talk about the garbage patches, we all hear about the Great Pacific Garbage Patch. But it's not the only marine trash vortex. It's just the largest. It's larger than this area of Texas. But we have smaller garbage patches throughout the world as well. The Atlantic and the Indian Oceans also have trash vortexes. And in fact, we have little vortexes in much smaller bodies of water, certain seas, for example, and even certain trade routes that are larger rivers end up with little pockets of trash vortexes. So it's a very widespread problem throughout the entire world. So the Great Pacific Garbage Patch, again, it's a multiple sets of garbage patches. So you think of it as just one large patch, but it actually is split up into multiple different regions, and it's going to cover the area here in between. We have both a western and an eastern, and the eastern one is going to cover, again, the area approximately of Texas, and you fly over it every time you fly from California here to the Hawaiian Islands. So it actually is a problem that's going to be basically in our surrounding water in the Pacific. So there's two distinct collections of debris. This one here is the western, and this one here is the eastern, and they're found in this subtropical gyre here called the North Pacific Subtropical Gyre. So I was just talking about microplastics, and this is what they look like. And microplastic is not, plastic is not degradable. It just gets smaller and smaller and smaller pieces, and these microplastics actually end up clouding the water to the point where it's impossible to even take a full drink or breath of water. If you're a fish, you're breathing it in. So you end up with this in your gills and in the lungs of the aquatic organisms that are like mammals, aquatic mammals. So it's going to be a very large problem. It's going to sit, the Great Pacific Garbage Patch is right on the surface of the ocean, but it's not necessarily directly on the surface even. It can actually sink several meters beneath the surface. So we can end up with a very large surface area and depth that's masked by trash, which makes it very difficult to actually measure the total volume or size or the surface area of the vortex. Again, most of that trash is plastic because plastic floats. Most of the other trash is going to end up sinking if it does end up in the ocean. And it's just going to make these smaller microplastics. Again, they're depicted here in the hand of an individual. And then often makes the regions of water look like a cloudy soup. So it makes cleanup efforts very difficult because we end up with smaller and smaller pieces of plastic waste. Now I'm going to take a second and read a quote to you from Captain Charles Moore, who was the individual who discovered the Great Pacific Garbage Patch. And he gave this quote to Natural History magazine in 2003. So, on the way back to our home port in Long Beach, California, we decided to take a shortcut through the gyre, which few seafarers ever cross. Fishermen shun it because its waters lack the nutrients to support an abundant catch. Sailors dodge it because it lacks the wind to propel their sailboats. Yet as I gazed from the deck at the surface of what ought to have been a pristine ocean, I was confronted, as far as the eye could see, with the sight of plastic. It seemed unbelievable, but I never found a clear spot. In the week it took to cross the subtropical high, no matter what time of day I looked, plastic debris was floating everywhere. Bottles, bottle caps, wrappers, fragments. Months after, I discussed what I had seen with the oceanographer, perhaps the world's leading expert on flotsam, and he began referring to the area as the Eastern Garbage Patch. So this is when we first realized that we had a problem, and it was far past the capability of an easy cleanup effort. Now, we have had several minor cleanup efforts, and I'll talk about some major cleanup efforts in a little bit later on in the next series of lectures and in the YouTube videos provided to go with this section. But here's some of the things that have been pulled out of the Great Pacific Garbage Patch. Everything on this page was pulled from it. And so we have microplastics, as I mentioned, but we also have much larger pieces of plastic, and a lot of these they've been able to date back to date of manufacture for the certain type of Batman mask, for example. And you can see that also when you get the chance to take a look at Boyan Slat's video. He is the CEO and founder of the Ocean Cleanup Project, and he has created a way to allow the plastic to come to the collectors instead of sending the collection out to get the plastic. And their project has resulted in the removal of quite a lot of that plastic waste, all of which is cataloged here. And again, they can tell you how long they've been around. Some of these have been around since the 50s, so some of this plastic has been here for a very long while. Most of the plastics are going to be coming from activities that come from like North America and also Asia, but some things are going to be coming from vessels that have lost cargo. Now, on that note, let's talk about some strange cargo that has been lost. So ships have a specialized type of insurance to make sure that they cover anything that's lost at sea, because sometimes when ships are caught in storms, the cargo just falls overboard. And so here's some examples of items that have washed up on shores. In 1990, a bunch of Nike sneakers were lost into the Pacific. And people in Washington and Oregon ended up finding all of these different sneakers all over and finding swap meets where they could match pairs. So I have a size 8 of this, does someone else have a left of that exact pair, etc. And they were able to find several sets of matched pairs to either wear or sell. In 1992, rubber duckies were released. The ship lost tens of thousands of them. In addition to this, they also lost turtles, beavers, and frogs all bouncing around in the ocean, which sounds really cute, but when you think about it being in terms of plastic waste, these are just as bad as something like an oil spill, although it is going to be a little bit easier to clean up if we're able to get out there earlier on. In 1994, they lost a bunch of hockey gear, so it had gloves, chest protectors, and shin guards all washing up on shore. So these are all examples of things that were lost at sea. So it's not everything that we talk about is going to be coming from shores. Approximately 20% of it is going to be coming from accidents with shipping cargo. And we blame a lot of stuff on plastic, but not all the trash is plastic, right? We have other types of marine debris, and some of the major problems with marine debris include nets. So this is an example here of a bunch of different types of nets. And nets can make areas that clog up the reef, right? And so they can end up creating these regions that are preventing algae and plankton to get sunlight. And then these guys are the very basic bottom of the food chain. So when the first organism in the food chain is threatened, the entire food web is put at risk, because the individuals that eat the plankton, like jellyfish, and then things that eat the jellyfish, such as turtles, and then even apex predators, such as sharks that eat the turtles, can all be affected by something as simple as this net that has been blocking the sunshine. Now, we saw this earlier when we talked about garbage waste, but I wanted to show that it was an albatross chick. Right, this is a baby, and albatross feed their young by regurgitating their stomach contents. So in this instance, the parents, unbeknownst to them, were regurgitating plastic waste into their offspring. And so this is indicative that it's a very large problem. It doesn't just affect the adults, it also is going to affect the infants, and in terms of seabirds, this can be devastating for their populations. But it's not just birds. Right? Turtles are also put in danger. There's an example of a turtle caught in a net, and if you Google turtle caught in a net, you get a ton of hits. I actually ended up with a very unfortunate video of a turtle with a straw in its nose, a turtle with a fork in its nose, and I would not post those links for you because I am very weak of stomach when I was watching that removed. But these are very real problems, right? Plastic waste is something that these animals encounter, and they can end up injured by, swallowing, and end up starving by, or tangled in so that they're unable to eat. For turtles, the biggest risk is going to be mistaking a plastic bag for a jellyfish, because they do look very similar with the way they float through the water, and once they ingest that plastic bag, they can have very severe difficulties digesting anything else because it can cause severe intestinal blockages. Another organism that's affected here is the Hawaiian monk seal. You can see this one is also caught in a net, and this is a extreme rescue effort where they've gone out and are attempting to cut this animal free. And this is an example of something called ghost fishing, which is a practice whereby people will just get rid of a net that gets tangled. It gets caught on the bottom, they can't pull it up, they're just going to toss it overboard or cut it loose. And that's because the fishing nets are relatively inexpensive. It's easy to get another one, and it's difficult to pull it off the bottom. So that leaves these residual nets that are fishing for nothing, right? Ghost fishing basically means that the nets catch fish, but nobody ever comes to get them. And so they just end up suffocating in these little nets until they end up dying. And here's an example of a Hawaiian monk seal, unfortunately, caught in one of those ghost fishing nets. So that's going to bring us to the end of our lecture. I appreciate you sticking through it to the end. It's a pleasure to meet all of you, and happy studying. Aloha.